All right, our last unit together this year, Unit 9. We're going to talk about bivariate data, and today we're going to talk about constructing scatter plots for 9-1. Well, bivariate data is where you have two variables or two numerical observations about the same item. And we're going to see if they are related to each other. Okay. So today we're going to talk about scatter plots. Scatter plot is simply a graph showing the relationship between bivariate data. Okay. So example 1. Example 1 is simply about constructing a scatter plot. All right. So step 1, we're going to determine appropriate labels and a reasonable scale for each axis. And then step 2, we're going to graph the ordered pairs from the table. We're also going to give this graph a title. Okay. So it wants us to construct a scatter plot of the number of millions of viewers who watched new seasons of a certain television show. So what's getting measured? The television show, right? So that is the title of our graph because that's what's getting measured. It's getting measured in seasons and it's getting measured in viewers. So our graph title is TV show. All right. Now when you're given a table, it's always given in an XY fashion. Okay. You have your x-axis and you have your y-axis. And so our x-axis label is seasons. And our y-axis label is viewers. Okay, so we have the title of our graph, the title of our x-axis, and the title of our y-axis. All right, so always make sure you have a graph title because titles tell you so much information. All right, so we not only do we want to make sure we write them down, but if we have them on a graph, we want to make sure we read them. So this is your x-axis title because some of your answers can be given in the title itself. Okay, and then this is your y-axis title. All right, next up, we have got to determine how much each block is going to be worth along the x-axis and where we're going to start that, and how much each of your blocks going up the y-axis is going to be worth and where we're going to start that. So my data in my x column is 1 through 6. Well, I have enough blocks, so we can start with 1 and go on up. Okay, and each block is going to be worth 1. So 1, 2, 3, 4, and I am labeling the lines, okay? Because if this is 0, that's 1 full block. 2, 3, 4, and so on. So this is 5, 6, 7, 8, 9. Okay? So I went above my data. Now, the y-axis. Well, we wouldn't necessarily want to start at 0 for the y-axis. So let's see what data we have. All right, so the y-axis, all right, your lowest number on the y column is 22.1, and your highest number on the y column is 31.7. So the numbers, okay, it should be below the lowest number, so 22, through and above the highest number. All right, so your numbers should run from 32 to 33, so that way you can get these data points within the number sets that you number. So we aren't going to start at 0 because the first 21 blocks aren't even being used. So I'm actually going to start at 22 here, okay? 22. So I'm going to start at 22. Now I have to decide if I can number each of these blocks, making them worth one block, and get to 32. So let's count it out before I put pen to paper and actually number anything, okay? So 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Ooh, okay. So I can get all of the numbers, I can get all of my data in if I make each block worth 1 and I number up through at least 32. All right, so this one's 23. 23, this is 24, this is 25, this one's 26, 27, 28, 29, 30, 30, there we go, 31, and then 32. Notice I only actually put numbers on the even ones just to give a little space, but I have, you know, right in here, that'd be 23, this one would be 25, all right? I just didn't actually put the numbers on there, but each block is still worth 1. Now, if you go and you're like, okay, this is my lowest number, and I'm going to count up, and you get up to the very top of your graph, and you're like, uh-oh, I didn't get the top of my data, then you go back, and you're like, okay, well, if I can't count by 1, what if I make every block worth 2? So then you would skip count and go, okay, each block would be then 22, 24, 26, 28, and you would count on up, all right? So, but since we did not start at 0, what you do is you kind of put a little squiggle below there, and what that squiggle signifies, all right, is that you did not start at 0. And you'll see that, all right, a lot on graphs when you're talking about the data unit. You'll see it on graphs on the state test and whatnot. So you see a little squiggle and your numbers don't start at 0. That squiggle means, hey, there's more of the graph down here. There's just nothing to it that we need. All right, so we have our titles. We have our lines numbered. All right, so now that everything is labeled, our last step is to actually graph these points. All right, so 31.7. All right, so x is 1, so I go to my one line, and then 31.7. That's 30, 31, 31.7 is somewhere above 31, but not quite to 32. 2. Okay, so my 2 line, and then 26.3. Okay, so we're going to go above the 26 line, but not to the 27 line. Line 3. All the way up to the 25 line. Okay. 4. Season 4. Season 4, 24.7. All right, so 24, not quite to 25. Okay. Season 5, 22.6, 22, but not to 23. And then season 6, right above 22. All right? And that's it. That's all you're doing when you're creating a scatter plot. We just plotted our information, all right? So now on the back, we are going to interpret. The state likes to have you interpret scatter plots, so we're going to learn a little bit and learn some vocabulary that goes with interpreting scatter plots. All right, so skip it over. Yep, I forgot. Copier sucks, sorry. Okay, so 3 steps. When we do this, step 1 for interpreting scatter plots, the association. Is there any association with whatever is getting measured on the x-axis to what is getting measured on the y-axis? Are they correlated? All right, so if whatever is getting measured in 2 different ways, if your numbers increase along the x-axis and your numbers increase on the y-axis, all of your data seems to be floating somewhat in the same direction up. Okay, so this is said to be increasing. This one in the middle. This one, whatever is getting measured along the x-axis has absolutely nothing to do with what's being measured along the y-axis. They have no correlation. They have no association. It kind of looks like it's snowing on the graph, and so this one is none. Okay? No no association. So if you say none in step 1, then that means you don't do step 2 and 3, okay? You would be done if the answer was none. Now, if as you go up the x-axis, your y goes down, and all of your data seems to be trailing in the same direction, this would be a decreasing association. Decreasing. Okay. Next up, step 2. Step 2, we're going to determine if we are linear or non-linear. All right. So if we're going to learn how to do this later. If you can put a line of fit, and you could basically split your data down the middle, and you could pretend this is a straight line. If you could make a straight line going through your data, splitting it fairly evenly on both sides, then this is what's called linear, okay? You can make that line. Remember the line, linear. All right, but if you were trying to split your data, and in order to do that, your line looks like your back has scoliosis, this is nonlinear, okay? We did not make a straight line, okay? Next thing, we are going to step 3. We're going to identify if we have outliers or a cluster, or both, or neither. Okay, so what is an outlier? Well, here's our data here, okay? And right here, you have this little guy. He is, out in left field, smelling the roses, picking flowers, while everyone else, they've come in the infield and they're trying to catch the ball, but this little guy is just like, they're going, I'm doing my own thing. He's an outlier. He's going to skew your data, which, if you get further into it, that's not going to make you happy, but for right now, we just got to know he's an outlier, okay? And then we have this little cluster here that's a little more saturated with dots than the rest of your data. So this is what's called a cluster, okay? So you have a cluster of data here, and that's just, where you have more dots compared to the rest of your data. So let's interpret 2 of them, okay? So when we have titles are important. I told you on the front, so we put them on and we read them. So we are going to best interpret the scatter plot, and it talks about hot chocolate sales, okay? Along the x-axis, we're talking about temperature. And then number of cup sales, okay? So as the temperature goes up, it seems your cup sales go down of hot chocolate, and that makes sense, because when it's 80 degrees, no one really wants to drink hot chocolate, all right? So does it seem associated? Does all of your data seem to be heading in the same direction? And yes, it does, and it's heading down, because as the temperature goes up, the number of cups goes down. So number 1, we are decreasing. 2, could we fit a straight line? Here, I'll grab a ruler so we don't have to pretend. And the answer is, yeah, I could kind of split my data and draw what we call a line of fit through my data, through kind of the center, splitting my data. And so, yeah, it could be linear. Yep. And then 3, do we have an outlier outside of, the data trend, or do we have clustering of more data points than any other area? Well, we have this guy out here. And what could be the explanation of this guy out here who seems to be an outlier? Because, it's not even 30 degrees. Well, maybe it was snowing or raining that day or sleeting that day, and the temperature was really not only cold, but, no one wants to go out for a cup of hot chocolate in the sleet and snow. So that has an outlier. Be careful on your assignment. When you are interpreting, you may not always have an outlier. You may have more of like a cluster. Okay? So we have now interpreted it going through our 3 steps. Example 3. What is the best interpretation of the scatter plot? Well, it's labeled math test. Okay, so we're measuring math test. How do we measure, what data points did we take for the math test? Well, we took the student's height and their test scores. Does your height have anything to do with test scores in math? No. No. And this, you know, it looks like snow. So there is none. There is no association whatsoever. All right. And that's it. There's no association. So we stop there.